Okay, so hello everyone. I'm Lorenz Cuno. I work at the University of Urbino, and I will be talking about using Xamarin to do multi-platform app development for Android and iPhone and so on. So, why are we here? The chances are, if you're here, you are already doing Android development, and you are, let's say, your target is to create great-looking applications that feel native, that feel great, that use material design, that offer a great user experience to your users in order to get great reviews, in order to get great feedback from users, to feel appreciated by your users, actually. So to exploit the platform for what it gives you and to create great app experiences from start to end. The problem is there are some people in the world that use iPhones, and there are some stubborn people that still use Windows phones. So in order to get those users, you have to actually create multiple applications for different platforms. And this is a great pain. Not only because the platforms are three, not only, but there are more of those, of course, but the main platforms, let's say, or two, more or less, 2.5. The problem is you have a very wide and very vast platform landscape. So applications need to run on Macs, on tablets, on I don't know, phones, of course, on watches, and also Windows Phone is moving to Windows Store applications, which run on big, wide screens, of course. So you have a wide range of experiences that you need to target specifically by writing specific code and by using all the platform possibilities, all the chances that the platform gives to you. And in order to do that, in order to offer a great native experience, in order to offer a great user experience, also a great UI, of course, you need to use all the tools that the platform gives to you, of course. Okay, so one way to tackle this problem is to use, for instance, HTML and JavaScript, of course. That gives you a common platform that runs more or less everywhere, but it gives you, let's say, a mediocre experience most of the time. It's not always, but it requires a lot of effort. One other way of reducing this problem is to take a platform, an existing platform, and just to stick it into another platform. Okay, so that's the Xamarin approach. Okay, so the point is, usually you have the so-called silo approach. Using you have 3 stacks for each platform. You have your iPhone application, your Android application, your Windows application. You write it using the platform tools, so you'd use Objective-C or Swift if you're very, very cool right now on iOS. You use Android Studio and Java on Android, and so on. The point is, you have to write the same application 3 times and more if you're targeting, I don't know, different screens and so on. So it requires a lot of effort. It's a great pain to do it, and you actually need to learn 3 very different languages. So it's difficult. So as said, the Xamarin approach is quite different. You just simply take .NET, the platform, and stick it inside Android, for instance. So the approach is this one. Okay? You have a square peg and you stick it into a round hole. Okay? That's more or less the approach. What you get from this is this kind of approach. So you have a shared backend on the bottom part, which relies on the .NET runtime and, of course, also exposes the .NET runtime to you as a developer. So you get all the possibilities, the power of .NET, and we'll see in a bit how this helps you actually. And on top of that, you actually create 3 smaller applications, so that the amount of specific code you need to write is reduced. Not only you will use native tools in those 3 applications. So you will not use some kind of abstract toolkit. You will use the actual, for instance, the iOS storyboards to the UI. You will use XML layouts and fragments and so on Android. You will use SAML markup language in Windows and so on. So you will use the native things in order to get the native UX, the native navigation experience and so on. So you have to design 3 different applications which can behave in very different ways in order to use the platform specifics. But on the bottom, you have a shared part, which you have to write only once. And the great thing is you have to test it only once. You have to debug it only once, and so on. So it reduces the time you need to write those 3 different applications. Also neat is you get .NET, but you rely on the tooling you already have. So you get the Android SDK, it works. You may use the emulator if you want to. You can use Genymotion if you use this. You can debug on real devices. It works flawlessly, and you get native applications. You get an APK that works on Google Play and can be installed right away. So no problem there. So what can you actually share? So the code can be split in two parts. And as you can see, the platform-specific part, of course, is bound to UI work. So you use the actual toolkit of the platform. You also have to handle the actual application lifetime. So application lifetime cycles are very different across platforms, of course. So on Android, of course, you have activities and fragments and services and whatever. You don't have those, of course. On iOS, it works very differently, so you have to handle this in platform-specific code. Also notifications, hardware access, of course, so if you are interacting with, I don't know, GPS, accelerators, sensors, whatever, those things you have to write specific code for the specific platform, of course, because things are very different. And also if you have specific APIs, so I don't know, for instance, media routers in Android, you get it only on Android, you have to use it using Android code, of course. But on the bottom part, you get a lot of things you can write once for each platform. For instance, if you do any kind of data processing, if you get, I don't know, data from the GPS, or for instance, you do a fitness tracker and you get accelerometer data and fitness data, you can process it in shared code. You have to write it only once and you debug it only once. Same thing for HTTP. Every application has to interact with some kind of API in the cloud, so HTTP you can write it only once with a shared API. Same thing for serialization and parsing, JSON, XML, whatever, you write it once. Caching, data access, important, so if you have any kind of database in your application, as SQLite or anything else, you write it only once, and anything concerning business logic, you have the opportunity to write it only once. And then you rely on specific things to do specific tasks, which are specific to that platform. And you get a great application user experience, one hopes, at least. So how does it look on the Android side? So once you have an Xamarin application, what do you get? You get an APK. So if you ever opened up an APK, it's a zip file, actually. So you open it up, and you can, I don't know, get a look around. And as you can see, you'll have the standard things. You have resources, for instance. You have the classes dex, which is a compiled version of your classes to Dalvik bytecode. But the great difference is these classes are not your application. This is the bootstrapper that actually loads the .NET runtime inside your application running on Android. So you get a VM inside a VM, more or less. And the actual code you write in C# or whatever is compiled to .NET DLLs, so .NET libraries, and they are found inside the assemblies folder, and there you get all your code. It's a lot of code in this case. So as you can see, there's the core libraries, the system.dll, system XML, system JSON, and so on. So you get all the .NET stuff compiled to DLL bytecode, to .NET bytecode, in .NET DLLs. And also your code is then compiled to similar DLLs and loaded by the .NET runtime. So it doesn't run on Dalvik, actually. OK, so that's what you get and what you can publish to the Google Play Store or whatever. What is available to you as a developer? You get a lot of stuff. So as said, underneath you have the .NET runtime, so you get everything .NET has. On the bottom, you see system.NET for network access, system for basic stuff, system IO for file access, and so on. Link, which we'll see in a couple of minutes, and so on. And on top of that, you get the Remapped Android API. So these are APIs that perfectly match the ones you get from Android, but they are rewritten to use the .NET style. Okay, so you only get it's a kind of facade, a wrapper around the API, actual API, and you get the 100% of the actual API. So you have no limitations, you get the whole package. Okay, you can write not native code just using .NET style. And as you can see, in the center you get C#. So why C#? .NET actually supports a wide range of languages, so you could write in C#, on F#, in Ruby, in Python, whatever, but the tooling, the best tooling you get is actually C#. It's the main language of .NET, and it's the language that exposes most functionalities to you as a programmer. So you get most of, say, dime for the buck with C#. But why C#? Why is it so great? Well, give me more or less 10 minutes, and I'll show you that C# is quite great. And it's like a revelation for you poor Java guys that you won't have to wait for Java 8 to do actually cool stuff, okay? Or if you follow the presentation before of me, you'll know you can already do that, but let's ignore that, okay? So let's go ahead with C# for now. What happens when C# meets the Android API? So the Android API, as said, is a perfect mapping of the original one, but it uses the .NET style, so it's a bit different. If you ever have written a basic Android application, you'll know that in order to listen to click events, you'll have to create an anonymous class, implementing the onClick listener that will override the onClick method, and so on and so forth. So it's quite a bit of code, and we've already seen in the previous presentation that there are ways to circumvent all this boilerplate stuff, of course. But one way of doing it in C#, the same thing looks like this. Okay, so you get, let's do it slowly. You get full generics, okay? So you don't have to cast most of the time. You get type inference, which means you can use var. Var is a way to say to the compiler, I don't care about writing the actual type of this variable, just find out yourself. So it's not dynamic typing, it's static typing, but the compiler does the work for you. And it's already a bit there in Java, but it's coming. So it's just already here in C#. And the nice thing is you have language-supported event handlers. So there's no listeners, no classes, no nothing. You just have the click event. You register using the plus equals mumbo-jumbo magic. Then you register the anonymous function. This is a delegate. It's called like this in C#. And you have a function registered to that click event. Okay, that's about it. And also, you'll see the text is not you're not using the set text method. You're using the text property. Just another way of saying the same thing. Okay, you're just assigning a string to the button of to the text label of a button. Okay, so that's more or less it. Now assume that you want to react to this button click by downloading a string over the network. Okay, asynchronously, of course, not blocking the UI, and then put the string you downloaded into the button itself. Okay, sounds like a lot of work because you have to do an async task in order to do asynchronous loading. You have to take the string and put it back into the button. Okay, in C# this can be done in 2 lines more, actually. Okay, so you tell the compiler, okay, I'm doing some async stuff by putting the async in front. You tell him to await for downloading the string over the network, okay? And this also magic by the compiler. It says, all right, I'm doing this on a background thread, and I'll get back to you on the UI thread as soon as the HTTP request has completed. We'll get back to this in a couple of slides, but just to get the feel of it. So this actually launches an HTTP request, and as soon as it returns, you get back on the UI thread there, and you set the text on the text label, and that's all you have to do. Okay, so the magic is done by the compiler, for you, actually. Okay, so a bit more details about events. As seen, this is the way of doing it in Java. It's quite verbose, actually, but it works. That's the way of doing it in C#. You get less code, and you have this nice-looking, more or less, functional stuff. Also, you can register, this is important because it's tricky, you can register more than one listener on the same event. Okay, that can actually be gets you some problem actually, but still, you can register multiple events and react multiple times with various event handlers on the same event. So that's more or less how you do it, and the functional stuff works like this. So C# has this notion of delegates. Delegates is just some kind of, let's say, a first-order type in the language that expresses a function. Okay. Some kind of functional construct. In this case, those are this is a lambda function, and as you can see, it takes 2 parameters, a and s, an integer and a string, and does something, returning another string. So the type of this thing, as seen by the compiler using the var word, is a delegate returning a string and taking an integer and a string as parameters. So that's the way the compiler interprets it and how .NET types that function. Okay, so you have a first-order typing of functions in your language, of course. And that's useful in Android for a couple of reasons. For any type of event handling, of course, but also if you have to, I don't know, delegate some kind of work on the UI thread, instead of having to write a runnable class, a class implementing the runnable interface and having to override the run method, you just pass in a function doing some work and you're done. Okay, so it's quite nice to see, perhaps. Other things, extension methods are quite funny because they look great, in my opinion. So you have static methods, and you can extend the interface of any class in your code, even if you do not own the class. For instance, you can extend the interface of a string, a basic string. Okay. For instance, you want to convert a string to a base64 encoding. That's pretty common. Okay. Instead of having to write a utility class and a static utility class, and you pass in the string and so on, you have to write a lot of letters. That's always boring. You write an extension to the string. As you can see, the second line actually takes string as a parameter, but the string is this. So the compiler assumes that you will be able to call that method on the string itself. Okay? So in your code, everywhere, you can write hello world, that's a string, and you call to base64 as if it were a method on the string itself, even if you cannot, of course, change the code of the string. Okay? So it's just syntax sugar, of course. Sugar coding, it works like in Java, but it looks nice, and it actually gives you less code to write, so it's always good. And an instance of this used in Android, for instance, is this code to pick a random string from a string array, from resources, okay? So you extend resources, and you just put in the code to pick a random string. So in your code, you can just write this, and it's a bit shorter, it's a bit neater, and that's about it. Okay, so that's just syntax for now. Other nice things in Xamarin for Android. Did you ever add an activity to your code and forget to put it in your manifest? It happens to me all the time. Well, or services or whatever. It's a pain. So why have to write a manifest at all? You don't need a manifest in Xamarin, okay? No need. You get it automatically. You just have attributes that's like Java annotations for you, like override and at whatever. This is the same thing, it's like at activity. So the preprocessor of Xamarin just takes a look at your activities, reads the label, exported, parent activity, or whatever, and so on, and builds the manifest for you, and that's about it, and you're done. Same thing goes for services and broadcast receivers and whatever. So it's a nice way to have the manifest built inside your C# code, actually, and not having to switch back and forth and wonder why the activity doesn't launch and so on. Okay, other neat thing, you have a real preprocessor. If you come from C or C++, you might like this stuff. I do. Why is it useful? Of course, in Java, you can do runtime checking. If you're, I don't know, debug mode, not debug mode, whatever, you can do that, but it's runtime, okay? You cannot hide code. You cannot avoid to compile some code to your APKs based on your compilation configuration, okay? So in this case, for instance, if you're compiling your code in debug mode and you want to be strict, and you want that if there's a problem, I want to have an exception, I want my application to crash in order for me to notice the problem, okay? So if in debug mode, you throw the application. Elsewise, if you have released the application that's running on a user's phone, you don't want it to crash, of course, and you just log the error, okay? So you can just switch the behavior of the application based on some condition, okay? And you can also, I don't know, switch behavior based on platform. You can have specific stuff for, I don't know, Windows Phone, for Android, for iOS, and so on in your shared code, okay? That's a way of doing it with preprocessor stuff. Also important, you might know that logging in Android is a pretty big security risk, actually, because sometimes you forget to put out your logging stuff, and you expose some kind of sensitive data to logs, which are not public, but more or less can be read by other applications. So one way, the good way to do that is to avoid logging at all costs when compiling in release mode. You need logs when you're debugging your application, but once you release it, you don't need them anymore. So how you do that in Java? You can do runtime checks, but runtime checks are runtime checks. So the actual call methods creating the log message exists, and the log message exists in your memory, actually. So there is a slight security risk still there. In C#, you get this fancy stuff. It's a conditional attribute. You put it on your log stuff, and simply this means the log method will be compiled if in debug mode, otherwise it will not be compiled. And the best part is every call to that method will be erased when compiling. So when you compile in release mode, this call will never be compiled, actually. So the string you're putting there, and which contains sensitive stuff, will never be in your code, or will never be in your memory, actually. So you reduce your security risk doing that. It's a small thing, but it's very, very neat to have. So that's the nice things. Now, let's go to the awesome stuff, okay? And you will see why C# is the one only real language you will need forever and ever, okay? More or less. So, as said, C# is statically typed like Java, and who doesn't like static typing? But it also supports dynamic typing if you want it. So one case where this is quite useful is when you have some JSON data and have no interest in writing complex parsing stuff. For instance, if you, I don't know, if you want to get the first URL in this thing, you have to check if the accounts property exists, then you have to access it, cast it to array thingy, and access the URL property, and then you get the string, perhaps, if it doesn't crash, okay? But who cares about this stuff? I don't want to write this stuff. So you use dynamic, you put it right there, and the compiler does everything for you, okay? So you have a thing, you access properties that do not exist. For instance, the name and the accounts array and so on. Those were never compiled, they do not exist. But the runtime will access those things for you. So you have to write zero code in order to parse JSON if you want to, which is quite nice. Other nice things, if you follow the talk before, you have seen that, let's see, for instance, you have a collection of things and you want to extract a subset of those things and put it into another collection. Okay, it's a quite common case, and in Java you usually do this. So once upon a time, you have a collection. Okay, for instance, you want to get a list of errors from some log files. Okay, you open up the directory where your log files are. Then you loop through the files. Then, if it is a file, you open the reader, a buffered reader on the file. Then you loop through the lines of the reader. Then you split the data. You check if the data contains an error. If it is an error, you add it to the collection, and so on and so forth. And assume you want to also, I don't know, to sort them by time. It's painful. You have to sort the collection and so on. Lots of code. Let's see how it's done in C# using the language integrated query, which is let's say a domain-specific language that allows you to express queries in language. And as you can see, it will be very short. So you get errors and you loop through, well, you access the files in a directory, first of all. Okay. Then you access the lines of each file of the directory. Okay. Then you split the line. Easy. You select only the lines that contain an error. You sort them. No problem there. Okay. And you select the information, actually. That's done. Okay. It's far clearer, actually, and it's far faster to write because you don't have to mess up your collection and so on. Of course, you can build a lot of code in Java to do this in a syntactically nice way, but this is integrated inside the language itself in C#. This is called link, in short, and it supports a lot of things. You can apply conditional operators. You can check, I don't know, if all elements of an enumeration match a certain condition. You can aggregate, you can join, you can intersect two collections, you can order collections in whatever way you want. You can pull out averages, counts, min, max, whatever you want from a collection of things. And if you notice, this looks quite much like SQL, actually, like SQL, no? Quite similar. In fact, it also works in databases. So you can write your SQL query in C# and it gets processed by the runtime, and it creates an SQL query, which then gets run on the database. And it works also on SQLite. So if you really want, you don't have to write strings and concatenate stuff and put in table names and whatever. No, you don't have to do that. You just write it in C# and it gets compiled to SQL in the runtime. Well, that's also neat and very fast to do. Now, assume that you have those error logs. And it's, I don't know, it's very slow because you have a lot of errors, of course. Who doesn't? Okay, you want to do it with multiple threads. So what you do, you use the task parallel library. It's a small library that works on .NET, and it works on every platform. So you get it on iPhone, on iOS, on Android, on Windows, on whatever. And you just do one call. You say as parallel, and it works on n threads automatically, just like magic. Okay? That's nice. Also, you can do the same thing in an imperative fashion. So you can just say parallel for each, and it will execute this function, this lambda function, on a collection using n threads, and it defaults to the number of cores you have, so it's quite fast. It can help you quite a lot. Okay, well, that's fun. Another fun thing is asynchronous programming. Who doesn't love asynchronous programming, right? So you get, I don't know, a button click, and you want to do something in the background, and you don't have to block the UI because it will freeze the UI, and it looks like crap, of course, and so on. But asynchronous code is hard to do. Okay, you have to ping pong between background threads and the UI threads and so on. This is simplified in Android using async task. It works quite nicely, but this is much, much nicer actually. So let's see. In this case, we have the onStart. It's the default onStart method on Android on an activity. And let's assume you want to download a thing, get an URL from the thing, download an image, and put it inside somewhere in your application, okay? It's quite common, let's say. So, sorry about that. What you're going to do is, this, of course, onStart runs on the UI thread, okay? You'll see the green parts are UI thread, the red parts are background threads. So what you're going to do is tell the compiler that you want to do async work by putting the async keyword on top. Then you say, okay, get me a string from the network in an asynchronous fashion. You await, and you get the HTTP request, and you wait till it completes. Now, what happens now is, by default, if you do that, the onStart call will be blocked by the UI thread while waiting for the HTTP request to respond, of course. So you get a nice UI freeze, which is bad, okay? Very bad. So what happens now with the await keyword is the compiler knows you are going to do it in the background, and it's going to return right away to the Android toolkit. And Android is going to act as if onStart already completed, okay? So for what Android is concerned, for the UI, onStart is done, and you're set, and nothing freezes, okay? In the background, you get the HTTP request. As soon as this completes, some magic happens again, and you get back on this method on the original thread. So you get back on the UI thread, and you can do UI stuff again, as if you were still in the onStart method, okay? Then you can parse the stuff asynchronously in the background. You can make a second HTTP request to download some image data. You can create a drawable in the background, and then as soon as the drawable is completed, actually on the background, you get back on the UI thread and you can directly put it inside your UI, and it will not crash and will not give you false thread access and so on. It's quite nice. So it's quite more complex than that, but it's quite difficult to explain how it works in the details, but let's just trust me, it works, and it's pretty great. Another thing you get in .NET is NuGet. It's the default .NET package manager, and what you get is a large collection of open source and not open source packages for your code, which usually, most of the part, work on any platform. So you get the same things that work on iOS, Android, and Windows. So you have still one code for each platform. Examples are the JSON parser, which is quite great, works everywhere, and also MVVM cross, which I will not explain, but it's a way of applying the model view model control. Model view model controller to Android and iPhone. So you get to use the same UI development pattern on all three platforms if you really want to. Okay, now on the darker side, the less pretty stuff, you have some issues in Xamarin. Okay, so for instance, as you can imagine, putting the whole .NET runtime inside an APK makes the APK larger, of course. And how larger? It's usually around 12 megs, which is quite big, actually. Okay, so it depends on your actual needs, but you get a lot of code in there that you have to put in your APK, and it gets on your Google Play application and makes your application quite large to download. So trade-offs there. You can, I don't know, you can remove some things here and there and get it lower than 10 or 9 megs, but it's quite painful. And honestly, yeah, you get a quite big APK. That's no way around that. It's less problematic on iPhone, because iPhone applications do not have the .NET runtime. They are compiled ahead of time, because iOS does not support dynamic code running on inside applications. So it's a bit smaller on iPhone, but not much. So, and performance. So you might wonder, I'm using a virtual machine inside another virtual machine. I'm using non-native bytecode on my Android smartphone. Is it bad? Is it better? There are some details, but usually just by the fact that the APK is larger, you get slower load times. Actually, it's perceptible. Let's say. Okay, so you get loading is a bit slower, of course. Also, problem is sometimes you will not be able to use existing Android libraries. So if you have a nice library you really love and you use, I don't know, via Gradle, or you have a nice jar file, there are ways to map them to .NET. They work, but not always, and it's a bit of a pain. So you'll have to switch to the NuGet packages, as said before. So instead of using the native Android stuff, you most likely will have to use the .NET packages. Also a trade-off, if you have something very important that you like on Android, you will not be able to use it in Xamarin, perhaps. Another big problem is cost, of course. Xamarin is not free, and it costs quite a bit. So if you are, you can try it for free. There is a starter edition, which is not very useful, actually. And then the first tier is $25 a month, so it's not much, but still not free. If you're a student, if you have any kind of academic affiliation, it's free, actually. So you can request free access and get it from there for free. If you work for a company or something else, the costs are higher and so on. But okay, that's part of it. And of course, another problem is you get one additional point of failure. That's not to underestimate. Okay, so you have one additional point. Your code is compiled on an alien platform. You never know what is failing, Android or Xamarin. You have one more point to worry about, actually. Okay, so sometimes it's not ideal. Some kind of errors you can avoid, since you can test on 3 platforms, so you see if the problem is yours or not. But sometimes Xamarin puts his own things inside, so you never know. Okay, so one more thing to debug, actually. All right, and performance. So as said, load times are slower. So this is a comparison between native Java, Cordova, which is a kind of a JavaScript framework, and Xamarin. Okay, so for instance, load times you see are slower, but not as slow as JavaScript in this case. And as you can see in this example, which I found online, I don't know if it's true or not, but downloading stuff and parsing it is more efficient on Xamarin than on Android. That's because the .NET runtime is a bit more advanced than the Dalvik runtime, let's say. So it has some performance enhancements that you do not get on Java. That's I don't know. That's funny to know, but actually in raw power computation stuff like prime crunching, you get no difference except that JavaScript sucks, of course. But that's natural, let's say. Okay, so final data point: we have worked on several applications with Xamarin. One of this is called Smart Road Sense. It's an application that gets GPS and accelerometer data from your phone and tries to evaluate the quality of the roads you are driving on. Okay, so there's a lot of statistical and mathematical code in there, and the beauty of using Xamarin for this use cases is you get to write it only once in C# and not 3 times for 3 platforms, and you don't get to debug it 3 times, which is quite painful, as you can imagine. So in this case, if you have lots of processing, of data handling, or lots of API accesses, it's useful. You share a lot of code. If your application is, I don't know, a social network of some kind with lots of UI things, you don't share much. Okay, so you have lots of code that target the specific platform, so you don't get as much out of Xamarin. In this case, it looks like this. So of 3,300 lines of code in C#, 61% are shared, 27% are for Android, and only 12% are for iOS. We have not worked on a Windows Phone app yet, but we will do that. So yes, you get quite a bit of sharing if you're doing quite a lot of work in the shared part, of course. If you do only UI things, stick to Java, and that's about it. So that's a bit. So should you use it? I don't know. Just evaluate. I like it because I like C#. Who doesn't? Who shouldn't? But still, evaluate, and it has some costs to it. So it's not for free, and it helps you, but sometimes it kicks you also as well. So just try it and see. You can get it for free if you're a student, or you can get it for free for trial. So okay, I hope it was more or less clear. Thank you.